Hi everyone. So my name's Lee and I'm here to talk to you today about some of my research using stable isotopes of carbon and nitrogen present in the dorsal spines of hedgehogs to track changes in their diet over time. Now, just for a bit of context, when I'm referring to hedgehogs, I'm talking about the Western European hedgehog, Erinaceus europaeus. Now, this is the only native hedgehog to the UK. And we used to find them quite widespread across the UK in a range of rural and urban habitats. So you'd often find them in places where there were hedgerows, broadleaf woodland, open pasture, grassland, and arable. So anywhere that was a green space which had a range of hedgerows and open space. Now, since the 1940s, the UK has experienced quite drastic hedgerow removal and more intensification of our agricultural practices. And this has made our rural environments a lot less inhabitable, in particular for species that are nest building, such as our hedgehogs, which rely on leaves to construct their nests. So this has made our rural environments a lot less inhabitable for them. We're now more likely to find hedgehogs in an urban location where their numbers are thought to be stabilizing or even increasing. So they've shifted their ecology. And now you might be wondering what an isotope is, though. So, quite simply put, what an isotope is just an atom. So, whereas humans are all humans and we all come in different weights, the same can be said for atoms. So, atoms are comprised of three basic parts. They have electrons, protons, and neutrons. And the number of neutrons that the atom has changes its weight and can make it either unstable or stable. And this is what an isotope is. So unstable isotopes decay over time, so they can be useful for things like carbon dating, whereas stable isotopes remain fixed in that sample, so it can be a great tool for learning from historical specimens. Now, a lot of research has been done into hedgehog diet in the past, and most of that research was either done by fecal analysis or stomach contents analysis. And these are great for studying diet, but what you're looking at in these kind of studies is the undigested remains of what that hedgehog has consumed, probably within about a 6 hour time period. So you're looking at really short-term patterns of consumption there. Now, where isotope ratio mass spectroscopy has the upper hand is what you're looking at there are the patterns of consumption over a really long time period. So you're looking at the elements that were consumed and metabolized in order to make that sample that you're analyzing. So it's really long-term diet patterns. Now we know that hedgehog diets are rich in invertebrates and insects. So things like worms, slugs and snails, beetles, caterpillar and fly larvae all feature really heavily in their menu. They will eat vertebrate prey where available, and this is usually in the form of things like birds, eggs, chicks and fledglings, or roadkill and carrion. Now, in an urban environment, humans provide a lot of other novel food sources for hedgehogs. So things like cat food, dog food, hedgehog food, leftover bird seed, and even our own food waste that we leave outside are all sources of food that are available in an urban environment. Now, these kind of novel food sources tend to be comprised of a really wide range of different plant-based ingredients, and they usually utilize chicken as their protein source, which is all very different from their natural diet made of insects. Now, isotopes can be great for studying food webs. Carbon is a reliable indicator of the primary producer in the food web. So whether there was more C3, C4, CAM, aquatic, or marine-based primary producers in that food web. Whereas nitrogen is a great indicator of your organism's diet. So whether it was herbivorous or carnivorous, with carnivores usually having much higher nitrogen than herbivores. It can also indicate life history stages. So things like if it was a nursing mammalian, you would see higher nitrogen than the adult counterpart. And also if that animal was experiencing stress, starvation, and overall diet quality. So we wanted to see if the hedgehog's shift in ecology from rural to urban and that accompanying shift in prey availability and dietary sources could be tracked using their isotopes. And in short, what we found was yes, it can. So we went and collected specimens from 26 different museum preserved hedgehogs. And we had 45 modern day specimens that were collected from roadkill or found deceased or donated in and around the Reading area. We tested at least 3 spines from each individual, and all our samples were measured in triplicate. We ran it through an isotope ratio mass spectroscopy, and we used correction factors accurate to 1850, so corrected it back to pre-industrial levels so that we could compare our museum and our modern day specimens directly. And we applied a generalized linear mixing model to our data. And here's what we observed in our results. So for our carbon results, what we did was we grouped our museum specimens into an early, which were pre-1940 specimens, a middle group, which were 1960 to 1993, and then we had our modern day recent group, which were our roadkill specimens from 2014 to 2019. And what we've observed here is a really robust declining pattern in carbon over time. So as time has gotten closer to recent days, you can see that the carbon values are getting more and more negative. So this suggests a really marked change in dietary carbon source. Now, for our nitrogen results, the pattern was a bit different. So what we saw was our early and our recent group were not significantly different, but our middle group was significantly different. Now, this could be down to the fact that we had far less samples in our early group than we did in our recent group. So it could be just down to that. Or it could indicate some of those life history traits. So it could indicate stress or feeding from a food source that's been enriched in fertilizers, such as those were applied on our fields. So overall, what our results show is there has been a really significant change in the hedgehog's diet over time. And we think it's mainly due to this change in ecology and this impact from these anthropogenic food sources. Now, this has got really far-reaching implications for conservation down the line. We need to understand what the impacts are on our hedgehogs from consuming an anthropogenically provided diet. We need to know what the nutritional requirements are of a hedgehog and ensure that we're catering to that. We're providing them with adequate nutrition. So this has got implications down the line for commercial producers, and it can really mean that they need to start to maintain some kind of quality standards in their food products. So isotopes are a fascinating way of studying food webs. This has been quite a whistle-stop tour, so I do appreciate it's been quite a lot to take on. But thank you very much for listening here. If you enjoyed this talk, then let me know. Please rate me for our presentation competition. If anyone has any questions, I would love to welcome them now. We're hoping to publish our results in a special issue of Frontiers that should be out next year. So if anyone would like to keep an eye on the results and our findings, then follow me by following this QR code on LinkedIn, and we'll update you when we've got more to share. Thank you so much for listening. Thank you.